your factory level or at your company level, then reusability of the program becomes much more, which means that becomes, I mean, that standardization is always your first step towards digitalization. If you eventually at some point of time would like to digitalize your entire process, standardization is a, you know, very basic requirement for that. So how standardized program which can be reused, such programming, how it can be done, this is also one of the topics that we'll be looking at. Unlike our usual way, I don't have much of presentations today, so I have compiled some certain set of links which I'll be sharing it with you at the end of the presentation, which will mostly we'll be discussing in this session as well. Sorry. Okay. So to begin with, once you start TIA portal, once you open TIA portal, most probably this portal view is the first view that you will be getting. And if you are like me, or if you would belong to the most majority of the engineers, automation engineers, portal view is not always the first view that you would like to have. You always either open a project and then go to project view, and this is where you do things, right? If it was a live session, I could have asked for more live feedback, but I hope you are like me, liking to do the things in the project view. If that is the case, instead of every time coming to TIA portal and switching it to portal view and project view all the time, if you like project view, I can show you one step. If you go to options and if you go to settings in TIA portal, so under general, we have some settings that we can, okay, so there are a lot of settings available here. What I would like to show for this particular option is coming up here, start view. So by default, the selection is going to be portal view in most of the cases. But if you wish to have the project view as your default start view, this is a place where you can switch it, and things will be okay. So this is one of the first tips that I would like to give you. Since we are here, let me also discuss some other configurations or some other setups what might be helpful for you. For example, if you come to hardware configuration, and hardware configuration has got an option called as product support information, which by default is deactivated. If you keep it activated, I'll show you what will be the effect. So let me open a project in my case. I have prepared a sample project just to save time in explaining different topics that we'll be discussing today. So in that, okay, so if you have this product support information via internet enabled, then you have the possibility that you can come to your TIA portal hardware catalog, maybe in the network view or in the device view, it doesn't matter. You can come to the hardware catalog. You can take any of the product that you want. You can right click on them and you'll be getting some options which will take you directly to the product support site. So if you want to know all the manuals related to this particular product, you select it, it will directly take you to our of course, you need to have internet connectivity in the system, but once you have it enabled, you are directly reaching it here with necessary filters and viewing all the information related to that. In the same way, if I could show you something on the CPU, for example, any one CPU, right click, I want to see all the FAQs related to that. So this is also an easy way to get the manuals or get some information related to a particular product easily from TIA portal itself. So this is possible once you keep the product support information via internet enabled. Fine. TIA portal, when you use it, most of the time you will need a little more of the screen space. So for example, if I open an FC or an FP, any block when you open, it will be better. Oh, if you have a screen with bigger resolution, then fine. But otherwise, to get little more space available on your block interface, or on your view, one of the step what we can do is all the comments that comes up in along with all the block title or the network, you can temporarily disable this. Of course, you can put it, but if you don't want to view it every time you look at a block, then you have the option to disable the network comments by going up here, and I hope that is visible for you. Okay, so if you look at this is what I was discussing about. So I can't zoom into that area, but this icon, what is available is nothing but a toggle button just to keep your network comments on or off. But this network comments on or off once you do it on a particular block, but that doesn't mean that every other block what you open will still be following that. Other blocks will still have the network comments and everything open, or even if you close and open the TIA portal, even then things will be remaining the same. Even for this, if you come back to the settings, if you come to PLC programming, ladder FPD, let me find out. Okay, so once you come to PLC programming, here you have the option ladder FBD STL. So you have the option to either make it enabled or disabled. So what I would like to do, I don't want to see the network comments all the time. Whenever it is needed, I'll look at it. That's it. I keep it disabled. Now if I open any block, by default network comments and all will be disabled, giving you a little more view space, so to speak. Okay, fine. Among the topics what I would like to discuss, one of the first topic that I had thought of is getting diagnostics of all these devices, all the modules what you have in the system is almost always useful for any project. So we have some instructions, we have some ways in which people take the diagnostic data. For example, just to show you, if I take one IO station, if I go in and add some, so let's say I'll add a digital output card, for example. So if I go with a standard digital output card, it's a 16 channel digital output card. So once we go to the properties, once we look at the output IO addresses, so 2 bytes of address it is consuming, which is expected. We know what it is. Now, in this case, if you want to have the diagnostic status or the channel status or the model status of each of this, couple of ways that you can do this is once you go to the program instructions, if you come to extended instructions, under diagnostics, you have the option of module states and device states. So these two instructions, I hope most of you are already using it. I'm not going into the explanation of these two instructions here, but programmatically taking this diagnostic values, I hope you are already doing that. What I would like to show you right now is another possibility. If you have the modules, which is at least basic, at least standard or high feature, I hope you know that, for example, 8200 SP and MP IO systems, different interface module and IO modules available are of different categories, which can be classified either as basic, standard, high feature, etc. So if you have a standard or a high feature card, then what I'm going to say will be available for you. So now, so far, if you have a look, output address, 2 bytes of output address is being consumed, which we know what it is. But now, if I go to DQ configuration, there is an option called as value status. This value status, once I enable, okay, before explaining that, now let me go to the IO address area. Just by enabling value status, what you see right now is for a digital output card, okay, for a digital output card, it is consuming now not only output memory area, which what we usually expect, but now it is also consuming some input memory area. To be exact, it is consuming 2 bytes of input memory as well. So what these 2 bytes of input memory is actually doing for you is nothing but it is giving you the status of individual channels, Now, it depends on the module, of course. If it is a standard type module, then usually the diagnostics is available only at the module level. So if even if any one module gets fault, all your input of that corresponding module will be showing faulty. But if you have a high feature module, which is actually capable of giving you diagnostics even to channel level. So for example, for a high feature card, right now, this is again an output card consuming only 1 byte of output memory, 1 byte, because this is an 8-channel card right now. But the moment I go to DQ configuration and enable the so-called value status, now if I come here, it is actually consuming 1 byte of input and 1 byte of output. Now in this case, so if Q 2.0 is your address, that particular channel status, you will be getting it in I 2.0 in this case. Same is applicable even for input modules as well. I was just showing it for output module. So for example, if I take a high feature digital input card, so have a look, this is an 8-channel digital input module what I'm taking. If I take it into my configuration, by default, an 8-channel digital input module only need 1 byte of input memory, which is what we see here, byte 3. So 3.0 to 3.7. But even for this module, if I come to DI configuration and I enable value status, now if I go back to the IO addresses, you will see even for an 8-channel module, now it is consuming 2 bytes of memory, which is nothing but 1 byte. The I 3.0 to I 3.7 in this particular case will be directly your input status. I 4.0 to 4.7 in this case will reflect the module, the channel status of individual modules. So without writing even a single line of code, you have the possibility of getting the module status and in fact, you'll have the possibility of getting even the diagnostics up to channel level if you have the corresponding card and just by enabling the so-called value status option. Only one point I would request you to remember in this case, that is for this option to be available, you need to have the modules, both your interface module and the IO modules what you take, it should at least be standard or high feature. Basic cards will not be having this option. Okay. So that was one first topic that I wanted to show, which is by how to take diagnostics without writing. If it was via program, then I hope this device states and module states instruction is already known to you. If not, the help file is pretty self-explanatory. Please have a look. These instructions are also really helpful in getting the status. Okay, so that was one. I'm moving into another topic, which quite frankly, it is a bit surprising that even sometimes even experienced programmers who are very much used to TIA portal or even Siemens automation system, even experienced programs sometimes miss to get the idea behind FC and FB. When we write program within the TIA portal or within the Step 7 platform, we have the concept of organization blocks, OBs. Then we have FC's functions and function blocks. So when FC will be used, when FB will be used, this is I saw sometimes, as a confusing topic for most of the people. So let me try to give you an explanation on that. And again, what I've mostly seen is, always using FB is kind of the safe way to do things, except for some extra memory consumption. There is nothing much wrong that could be happening while using the FB. So I see people tending more towards FB, which is totally okay. But as I said in the beginning, if we reach to a point where we want to optimize memory consumption, if there is a possibility, then why not? Let us make use of FC itself. But when to make that decision, or what differences will FC and FB give, let me give you an idea. I'm not going into the very, very basics. I hope you all know that FC, when you call it, there is no DBs associated with that. But when you call an FB, a function block, always you have to give an instance DB for every block call. Okay, keeping that in mind, let us start one of the first FC. So I have prepared one FC here. All I'm using this for is to calculate the average of two numbers. So I am taking two real numbers as input. I have an output, which is nothing but the average value. And of course, to calculate average, I need to have the sum stored somewhere, which is not my final result. So I make use of the temporary variable in this case. Okay. This program, in fact, is always okay. There is no problem. There is nothing wrong with that. The place where people tend to make misconceptions is mostly about the usage of temp memory area. So before giving you a demo, let me first say you some things. Let me just tell you something. You can think of using temporary memory area only when if you're sure that you're writing some value into the temporary memory area and you're consuming it within that scan cycle, within the end of that program execution itself, within the end of execution of that block. If you want to read the temporary memory area without writing anything into it, or if you expect that you store something now and in the next or the future scan cycle you would like to access that, temporary is not the way to go ahead. But in this example anyway, when I'm calculating the most complex average, here it is totally fine, because all I'm doing is at first I am calculating the sum, writing it into that temporary variable, and within that same, before the end of this block execution itself, I am consuming it and giving it as some other result. That's fine. So let's have a look at it. So if I call that FC here, I also have prepared one DB with some random variables. Now, this DB variable, if you want to connect it over here, okay, this is another point. Of course, we can type the values and take the data. So I know that the name of the DB is demo DB. So demo data dot number A1, you can type it like this, or you always have the possibility of drag and drop in TI portal. So for dragging and dropping, let me show you some methods. If you use the split screen option and use one of the panes to open up your DB, yes, this is one way that you can make use of the entire screen, and you can easily drag and drop instead of doing the same, typing the entire addresses. Other than this, another possibility would be, if you know about under the project tree, there is a so-called details view. This details view will give you a peek into the object what is selected in the project tree. So right now, if I am selecting my program blocks folder, under the blocks folder, what are there, I can have a look here. Similarly, if I open it up, and if I select that DB, inside that DB, all the variables what are there, I can see that here. So this is even applicable for tag tables, for example. So this is another method which you can make use to ease your life in programming and just doing the drag and drop option. Okay, done. So a small program, I'm using an FC, doing some small average calculation with the help of utilizing internally a temporary variable. Let me try to download this. I don't have a real controller here with me, so I'll take PLC Sim Advanced for the simulation. Okay, I'll start a PLC, maybe PLC A, something. Start. Whenever you want to use PLC Sim Advanced, the only one step that you need to do for the project is go to the project properties and make sure simulation is actually enabled. Support simulation during block compilation is enabled, which I have already done in this case. Okay, so my things are done. I'll try to download. Loading. I can have a look here how the CPU is actually behaving. You will get to see the LED status as what it is available on the CPU itself. Yes, consistent download, load. And once the loading is complete, I can ask my CPU to start, which will reflect here showing in the LEDs. Okay, anyway, I'll minimize that. So my downloading is done. I go to monitor mode, I monitor everything. I come to the DB as well, and even the DB I can monitor. I can modify the variables here or here. Let me do it. It doesn't matter. So if I go to modify operand, I give, I don't know, 11. And the second one, modify 33. I get the average without no problem. So this is the common use of FC. And to be more specific, I'm trying to concentrate on the use of temporary memory here. Keeping this basic understanding in mind, let me go ahead and open the second block what I have. Go offline. So the second block what I have here is actually used to calculate the the run hour of a motor, a device, something. So all I have is actually a Boolean input where I'm expecting some pulse per second. I'm calculating that seconds, and that second information I'm using it to finally calculate the total run hour. To do this, my block actually has only one input and one output. So which is, if I open the block, so I have my run pulse, which I'll be giving it here, and the final run hour, I've made it as an in out. That's why it is appearing here. So I give the pulse every second when the motor or when the device is running, and I get the run hour calculation here. Let us have a look at the calculation, what is done internally. So whenever the pulse input is coming up, I am incrementing the second. So this second is actually a variable what I have made in the temporary area. So I am incrementing that second one by one. And if the second value, oh, sorry, I forgot to zoom in. Okay. If the second goes above 60, I am incrementing the minute, and also I move the value 0 to seconds. And similarly, if the minute goes beyond 60, I increment 1 in the run hour and I move 0 to, so, I mean, basic calculation is what is being done here. But the most important point I want to show is here, the seconds variable and the minutes variable, I am keeping it as my internal temporary memory. And I hope you already see the point here. This first time when I am adding this seconds, so when the first pulse come in, okay, by default, the second variable will be having the value 0, of course. So 0 plus 1, 1. And in the second scan cycle, that 1 what was stored in the previous one is actually expected here. This will not happen. Let me show it to you. So if I go to my this one, I had made some variables for this as well. Okay, so I have some. So what I have done, machine 1 run, and I have enabled the clock memory in my CPU. So I need a pulse to be given there. So let me give the edge bit over there. And I have the run hour of machine 1, which I'll calculate like this. That's it. I'm calling it only one time, and the program is pretty simple. I'm just doing this. So let me download this. Load. Okay, so here monitoring will be a little bit tricky because since I'm taking a positive edge, I might not be able to see that pulse going in. But anyway, let's give a try. So if I come and split the screen up, if I monitor this block as well. So what you see here is I'm going to make the run feedback on. So when I make it on, ideally, I should have got the second variable incrementing here. But what you see is nothing. This pulse, since it is actually just an edge which is on only for one scan cycle, you're not able to monitor it exactly. But eventually, nothing, no change is happening inside this particular block just because we have made it as a temporary variable. And in a temporary variable, what happens is at the beginning of the execution, you get the temporary variable. When this block FC2, the last network is completed, that temporary variable is removed from the scope of this FC. It goes back to 0, we can consider. This is the scenario where you need to have a local memory for the block what you actually are creating. the first example of the average where you were writing something into that variable and then reading it was totally fine. But now here you are writing and you expect that value to be retained or value to be available there even after some certain machine cycles. So in such cases, we do not recommend, I mean, we cannot use this so-called FC concept with temporary memory internally. We have to go with FB. So at least let me show you whether the FB in this case will, with the same logic, will work or not. Now to show that, okay, I can create a new block here like this. I'll call it, okay, some name block, but I'll make it FB. Copying this is a huge task for me. If I open up that FC, I split the screen, I can almost copy everything and I can paste it here, but then all the variables are, so copy pasting FC, FB is going to be a big task for me. Let me tell you, if you feel, oh, why am I doing this? If you feel like that while using TI Portal, remember there is definitely some easy option available for you to do that. So this FB, what I created, I'm just deleting it. Let me introduce you to the concept of TI Portal add-ins. With TI Portal version 16, if you have noticed, your TI Portal on the right side, you have a folder, I mean, you have a separate tab here as a task card called as add-ins. This is the one that I'm speaking about. So if I go into this add-ins, this is using the concept of TI Portal openness just by writing some code in, I don't know, maybe C# or VB. Any .NET framework, you can create an add-in, and that add-in you can insert or you can add it into your TI Portal to leverage its functionality. The 3 add-ins what you see here are actually available in SIEMENS site. It is already published. So if you go to, I'll be sharing this link as well. So we have an entry with a lot of downloads available. So this add-in functionality, how the add-in is actually used, where to install it, how to install it, or even if you want to create an add-in, there is even some application example where you can you get a sample code and you can go ahead and create your own add-in. So all I have done here is I have installed some add-ins, and one of the add-in available in the support site is, as you see the name here, FCFB converter. Since I have added this add-in and I have enabled it in my TI Portal, now what I can do is, so this was my FC, right? FC2. So I just make a copy of that FC for the time being. I paste it. So this FC5, let me name it demo FB. I know it is still an FB, but now all I'm doing is I right click on this. I have my add-in section here. Under that, if I go to FCFB converter, second, I have, so since I am right clicking on an FC, I get an option to convert it to FB. So all I do is that it compiles the block, it converts the block into an FB, and here you go. You have that block with the same set of code what you saw before, but right now, the only change I want to do is all the variables which we had declared previously inside the FC as temporary. Now I want to have them under static. Now that is one difference between FC and FB. I hope this is again a known fact to you. FB has got a memory area called as static. And what static is doing, or how static is different from temporary memory, is just that static will be assigned a specific memory inside the instance DB. So when you come to the main program and when you want to call that FB, so when you call it like this, every time you call an FB, a DB will also be assigned for it, right? So in that DB, if I open that demo DB, what is created, our static variable has got some dedicated memory there. So even if you want to access this in some later scan cycle, this is totally fine. Now this, let me do the same logic up here. Whatever we did before, I'm just converting it into this FB logic, and now let me delete this network. So same logic, even internally, all the program, everything is same. Only change I did was I've taken the variables from temporary and I've put it in the static. Only because I want to have access to those values even in later scan cycles. Done. Let me download. If I go to monitor mode. Oh, this was already on. So open and monitor. Now you see here already, see, since the machine run feedback is given, my seconds variable is in fact increasing. So some change is happening, which we did not saw in the last one. And if I stop this, no, stop to 0. And that's it. So 30 seconds, it is just remaining there. So this is one of the case where an FC will not help you in doing things. You will eventually end up with FB, and especially the use of temporary. So if there is a possibility for you to use temporary, please try to go ahead with that, because temporary will not consume much of your code work, data work memory. But if you do it in static, which is eventually coming up in a DB, that will consume your data work memory. Okay, so that was one of the demo what I wanted to give. Moving ahead, let us go to a next example where FC might not be your right choice. I have an FC here, the third FC. Okay. So this is in fact the same concept as what you had before. So this program is, all it is doing is it is just having two inputs and one output. I'm just latching that output with the help of this latch bit. So I'm using an SR block. I know some of you might be thinking, no, I need not do this program like this. I have some easy way to do this. I know this is just for a demo, but if you end up doing something like this, I just wanted to show you the bit what you give on top of the SR block is actually retained there so that you will get the output even in the next scan cycle. Let me show you what I mean by that. So if I call that FB and if I open my DB, I'll take, I'll take say machine 1 start, machine 1 stop, and machine 1 conveyor output. I'll give us the contactor. So simple. And internally, all that is happening is it is just latching, but this latch bit, what you see here is something that is saved in the temporary bit. So the same topic that we discussed just before, but just to give you a demo that even, because these are all some cases what I have seen in certain programs, I would say. Put that monitor. Okay. Now here what will happen is if I go ahead and modify this to 1, yes, my set bit is high, so because of that it is latched. So since it is a SR block, what I expect when I take this input off, the output should remain there. But what you see is that the output is also gone, because the latch bit is again inside a temporary, and the same topic, the same explanation. Okay, I'm not going to give you a demo of converting this into an FB anyway. I hope you got the idea. Okay, next one, or the last one in this particular scenario. So here, the simple FC, all I have done is I have just one input and one output. If I get the run status, I want to give an indication lamp on, which is pretty simple. Nothing in between, no lamps, nothing has come up in between. But here, all I want to do is I want to introduce a little bit of delay. When the run status come up, I don't want the output to be turned on immediately. I want the output maybe after 2 seconds. So I have my awesome timers for this. I take the timer and I call the timer. Since timers are also internally basically some FBs, so it will also ask for some DB. So I'll name it timer 1. I've given the timer there and I can mention the time. So T hash 2 seconds. So after 2 seconds, I expect the output to be on. Okay, pretty simple, pretty straightforward. Let's call it. So I want to call this FC twice. Okay, and internally what I want to do is, if the machine 1 run is there, then I want the machine 1 indicator to give a status. Similarly, if the machine 2 run is there, I want the machine 2 indicator to give me the status. So what will happen in this case? Let's have a look. Download, load, done. I go to monitor mode. I modify this to 1. And if I count 1, 2. So 2 seconds over, and even then I don't have my output here. So something went wrong. Let me modify it to 0. If I do the same thing here, modify to 1. So 1, 2. 2 seconds done, even then, even here the output is not coming up. But if I do the thing for both of them, yeah, then after 2 seconds, both the outputs are turning. So what is happening here? The only explanation for that is, in this particular case, internally, the timer that we are using is actually common, which you already saw that, right? So if I open up this guy, for both the block calls, a single timer is actually working there with a static reference to this particular DB, DB3. So eventually in the main block, what is happening is, when the first network try to make it on, the second network try to make it off, and the same timer is pretty much confused until and unless both the inputs are on. And that's what was behaving, that's what was causing that behavior, what we saw. So how to overcome this? Of course, FBs can come for rescue in this case, but I also want to show you some other topic here. Instead of creating a timer in this way, I hope you might have noticed this. When I call the timer here, when I'm asked to give a DB for that, I also have got an option here called as parameter instance, which means instead of calling a single, or instead of giving a single DB as an instance for multiple calls, I now have the option of giving a timer. I'll be able to pass on some timer along with my block, just for the sake of keeping that timer different. So let me give some name for it. So delay timer, some name. Okay. See, it is coming with a hash symbol, which means it is available in the block interface, and no DBs are assigned to this. And by default, it got reflected here in the in-out area of my block interface. Okay, fine. I'll just give the time t hash 2 second. Done. So is that it? Done. Let us go back to OB. Now you see that since our block interface has changed, the the block calls are showing red. I can update the block call here by right click and do the update block call. I hope this you all know. But let me show you also one other method. If you have multiple block calls in the same block, and if you want to update all of them, rather than right clicking and doing this one by one, let us do it in centrally. If I go to options, block call, update all block calls. So you have an option up here. So now once I update it here, now I get to see a new in-out variable asking for a separate timer. So now here I have already prepared, given one timer before, that was timer 1. So I'll give timer 1. I'll make sure that the second time I don't give the same timer 1, I'll pass on a different timer in this case. But how to create a DB for timer? It is pretty simple. You can just click on add new block. You go to data block, and in data block, global data block is mostly the one that we see. But if we scroll down, we also have the option of IEC timer, counter. All those blocks are available here. So I just make a new DB of the type IEC timer. Let me call it timer 2. Done. It got created under the system resources. Okay, and now I'll give the timer 2 here. Done. So 2 times I'm calling, and each time, instead of giving as internally a single reference, I'm passing 2 separate variables here as the reference. Let me download. Done. Okay. Now things will be okay if I modify to 1, 2. After 2 seconds, the first output is on, no problem. And the same for the second, modify to 1, 1, 2. And after 2 seconds, the second one is also on. So when you call any block that requires a DB, I mean, I was showing this with the help of a timer, but this is equally applicable for timers, counters, or any other block that you call from the instruction list which requires a separate DB, or it is also applicable for any block that you have created that requires a DB, which means any of the FB what you create, this FB for any reason, if I'm calling it up here, that will also need either a single instance or a parameter instance. So if you plan to call this FC multiple times, don't give single instance, then it will not work. But okay. Now, this solution, what I just came up with for this particular case of just giving a delay for a timer, this is okay. But it is, I mean, hell lot of a task for a programmer. Every time I want to call this, I have to create a new DB. I have to make everything here. This is not the efficient way of doing things. And we are not here to discuss an inefficient way of programming, right? So this is where I would like to introduce another possibility inside an FB, which you might have seen it called as multi-instance concept. So let us go back to that demo FB what we had. We'll do a simple, I'm not creating some new FBs. I'll just add run feedback, if I can type it right. Oh, okay. And in the output section, I'll make a lamp, which is a Boolean. So somewhere down below, I'll be creating one block like this, which I can now make it run feedback given to lamp. Done. Now, if I want to introduce a timer within an FB, when I call any other FB that requires a DB, have a look. You will be getting one new option that you haven't seen inside FC. You know what single instances, you know what parameter instances, but only for FB, you have this option called as multi-instance. So if you make use of multi-instance, this variable will be created in the static area of this FB so that your FB becomes self-sufficient. Every time you call that block, you need not go ahead and manually create another DB for timer, another DB for counter, nothing required. Your FB is already self-sufficient with the concept of multi-instance. So let us have a look. So timer. Okay, delayed timer. I have given the name, it came with the hash, but since I chose the option multi-instance, it did not appear under in-out. Instead, it came under static. If you had given the option single instance, it would be just another DB natively, right away created on your blocks folder. If you have given the options parameter instance, it would have appeared under in-out, just like how you have seen it in the FC example. But since it is an FB and we have the possibility of multi-instance, it came inside static. Now, because of this timer, will my block interface change? Absolutely no. So let me give some t hash 2 second time. If I go to my main, let me delete them. I'll call my demo FB here. For that FB, I have to give a DB, I know, which is okay. I'll give one. I am asked to give my run pulse, which as we have done before, let me give it. So run demo data machine1 run, and I can m0.5 demo data edge. See, already typing is becoming a hell lot of a task even for me. So let me go ahead and do that. The edge run feedback I would like to give from, I don't know, I'll give the same run for the time being, and run hour, give something up here, and for the lamp I'll choose the indicator, and done. So the block interface is not asking for any DB, any timer DBs or anything to be given. I can just download my block and the internal timer what is available will take care of the rest. So if the run is made to 0, the output, the indicator lamp is also off. Okay, so as I said, just the point to remember is that this I was showing you with the help of the timer instructions, but the same is applicable for other blocks as well. So let's say you have prepared, you have an FB for your motor control and valve control, and you want to call that motor block 5 times. So you can call it inside another FB, and every time you call it, then that DB what is required, you can make it as a multi-instance DB. I hope we'll see some examples for that even. So with this, I would like to conclude the discussion on FCFP. So to summarize the points what we discussed, differences between FCFP, most of you know. FC, when you call it, there is no need for any DB to be given. FB, function block, when you call it, a DB has to be given. But the real, purpose behind that DB or the usage of the DB comes with the usage of the temp memory area. Temp memory area is something which is available in both a function and a function block, but you have to be careful while using it. If you are using, always keep this in mind. Write a value into a memory, into a temporary memory, and consume it within the same scan cycle, you're good to go. But if you write something in one scan cycle, and if you wish to have it in some future point of time, then you need to consider FB, because that provides the static DB option. That is one. So temporary, static, that is one difference. Another point is with the help of FB, we have the option of multi-instance DBs. So any other block, may it be timers or may it be other FB, which requires a DB to be given, you can make it multi-instance. And the biggest advantage is your block is becoming more and more self-sufficient. You need not depend on other blocks. You need not manually create n number of blocks, even if you wish to reuse the same block in future. So that is the whole idea behind this. Okay, I hope that discussion was any bit of helpful for you. Let us go to the next topic here. I don't want these. Let me delete them. I don't want these as well. Okay, all up to date. Go offline. Fine. Second topic, a totally different topic that I would like to discuss is regarding addressing. Now, I hope you might have already noticed in this demo, or if you have attended any of our previous demo sessions, or for that matter, if you have seen any application examples or libraries available from our support site, most of the times you might have seen that we always use DBs, data blocks, for storing data. We are not using bit memory for storing data. Bit memory is still available. I totally know, I totally understand. But the recommended way of storing data, whenever you want to store data, always use DBs. Why we are saying that? With the with the firmware or with the hardware of 1500 and 1200 series PLC, the data blocks can be optimized by itself. You need not do anything on. So let me make a data block with the name data. So when a data block is created, inside the data block, when you go ahead and create some variables, you can make those variables by knowing, how many bytes it will consume, how to arrange it so that it won't, waste the memory. But now we have the optimized block access, which, by the way, is the default option always available. And we always recommend keeping this optimized block access. Don't remove this. No problem in removing, but if you keep it optimized, you don't have to worry about addresses. TIA portal, if you follow the latest, not just something what is released in version 16, from the beginning, all these features are available. If you follow that facilities available, as a programmer, you need not worry about address at all. You only play with symbols. symbolic names are easy to remember, easy to access, rather than remembering some random address like db14.dbw32. Instead of going ahead with that, you can easily remember addresses and easily remember symbolic names, and that is what we give it to you. So keeping the optimized block access, you just use the symbolic addressing and symbolic accessing of the variables. You totally forget about all the individual address that plays behind that. Let the compiler take care of allocating memory, and the compiler take care of allocating all the required resources for that. Okay. Now, with that, especially people who have used some people who are used to the S7 300, 400 or the classic platform, we get a lot of questions with that. So this demo, what I'm going to show you right now, is mostly to address those points. So I have an FB created here. I mean, it could have been anything, but I'm just creating an FB, not going to run any things in the PLSystem Advanced, just to show you something. So let's say we have some individual bits, array of bits or individual Boolean bits, data coming from different places. I want to combine it into a single word. One of the very common example I'm pretty sure all of you might have faced is when you want to create some alarm tag for HMI panels. You know that our HMI panel does not take the bit, a single Boolean bit, as the alarm trigger bit, right? We have to combine it into an integer, which is actually 16-bit size, and then take it. So that's what I want to show here. So let me make some bits. So bit 1 Boolean, and this, I hope you must be already aware that we can drag and drop just as how you would be doing it in Excel, even inside the DBs, inside the block interface and all. So I have some Boolean bits coming as input, and I have an output here, which maybe alarm tag. Okay, this alarm tag is actually a word or an integer, doesn't matter. So it is not a Boolean, it is a word. All I want to do is I want to save the data inside each of these bits into the corresponding bit in that particular alarm tag. Because if you remember some past programming what you have done in terms of creating HMI alarms, I hope this must be very familiar to you. So for doing that, people go around with different ways, but I want to show you a simple addressing mode or addressing possibility available here. So let me take this as bit 1. And if I just drag and drop this, definitely this will cause an error, because this coil instruction can only take a single bit, and alarm tag is not a bit. But in TIA portal, it allows, especially with 1200 and 1500, we have an addressing concept called as slicing. So if you have a symbolic access that you are actually doing, but from a word you want to access a single bit, or from a word you want to access a single byte, we have an option called as slicing access. I'll share this link in the presentation, but let me show it to you what I mean by that. Once you give a word type tag or something like this up here, it will show error, yes, but you just type dot B0, B for bit. So once you do that, okay, what is happening? Let me have a look. Dot. Am I making a mistake? Okay, dot B1. Let me try to put it inside static. Oh, sorry. B is for byte. My mistake. It should have been X. Dot X0, if you give it, that is a single bit. So this word, once you have it, my mistake, sorry for confusing you if I did. Okay, this word that you have, individual bits of that word, you can access it by slicing access. with the help of these keywords. Now, word completely, that word, if you want to access individual bits, then you make use of the .x option. So bit 2, bit 3, whatever. Here you come to .x1, .x2. It can go up to how much ever size is available here. So this is a word, which means I can give it up to 15. But now if I try to give it as 16, it will start complaining because that's a word and 0 to 15. So totally 16 bits is what it has. So this is a possibility. As I have already shown you by mistake, this access is also possible via single byte access as well. So let's say for some reason from this word, what you have, I need B1 byte, which is a byte, and I need the second byte, that is maybe B2 byte. Now, if I call that guy here, sorry, if I call that guy here, and if I put a byte here, this will cause some data loss because this is a word. We are compressing it into a byte just by doing this, and we are actually only moving the last 8 bits of that particular 16-bit word. But instead, if you do B0, which is for byte 0, and if you want the second byte, you can just do B1, and you will get the second byte out of it. So the tag, what you define, if you look at your block interface, it will just appear as a single word type tag itself, but that word, you are slicing it into different bits, bytes. So if you have a double word, you can slice it into booleans, you can slice it into bytes, you can slice it into words. That is also possible. So if you want to slice it into word, you will just use the identifier W for that. So with the help of this, you will be able to easily access individual bits and individual words, bytes from the status, all these options. Let me also show you another example or another use case for this. Right now, what I have shown was certain bits I am receiving from the field. I am converting it into an alarm tag. But instead, now what I want to show is maybe via Modbus or something, I'm getting some value. I'm getting a 16-bit holding register. So maybe holding register. It's a 16-bit value. You know that. So holding register, a word I'm getting up here, and the place from where I'm getting this holding register 1, that holding register, each bit refers to some individual status. So maybe you are combining the status of 8 different valves. So 8 valves, open and close status, you are combining it into a single word and sending it as holding register 1. So now you want to access the individual status. So valve 1 open, which is a boolean, and valve 1 close, valve 2 open, valve 2 close. Let me just make 4 more. Okay, not C2, V2. Valve 3 open, valve 3 close, valve 4 open, and valve 4 close. So this is 16-bit. I'm just trying to show it to you for 8 of these bits, not much. So here, now when I take that option, just like before, we have the possibility right now to do this. Not only in the output byte, in the input byte, I can drag and drop that and say .x0. Okay, .x0 is val1 open. If only it was, just simple as this, it would have been okay for you. But most of the cases, maybe you want this access acting as an interlock for starting off some pump. So when the valve is open, then you want the pump to be on. So you will then be doing, some on command. You will be giving some on command to some pump in this case. But tomorrow, when you come and look at this particular program, When you look this holding register %x0, you don't understand what that is, right? So with the slicing access, we don't have the full efficiency of having the symbolic names. So for that, I want to introduce you to the next topic what we have. This is the concept of at keyword or at overlaying. The variables what we have in the block interface. So if I make it, this has to be set in IDB for this to work. So the very next variable, if I create, so var or status, you see this is actually acting as a separate variable with the same type, word, int, bool, whatever it is possible. But once you keep this option, now you have the possibility to just type at there. What the at will do, AT will actually overlay this status on top of that holding register one. So let me make it simple. So I'll call it HR1. I'm sick of seeing that. So this status tag is right now overlaid on top of that. Okay, so to keep things simple, let me delete all the old ones. And here I'll delete the alarm tag as well. Okay, so this we can see it from here. So if you look at it, so here we have a dot, but if you see for the status, this place there is no connector available, showing that that is not a separate tag. It is just a continuation of the previous tag available. Now, what is the advantage? Advantage is that once we have this, now instead of making it a word, I can now make it as a structure. So I'll make it as a struct. And under struct, I can now put it like this: v1 open, v2 open. And to make it easy, let me copy these names over there, copy. And if I paste them up here, so this is actually a 16-bit sized variable. I have already pasted around to open, v2, okay, v1 open. Okay, so I've already used 8 of them, and the last one maybe I'll keep it for future use, which is just a byte. So 8 bits plus a byte, which means totally 16 bits, all overlaid on top of that particular word over here. Now, if I come down to my program, if you now want to use it as an interlock for something, or if you want to use it in any of your program, you can directly make use of this. Okay, this can be given down to your output. Now, this does not mean that your block interface is changed. So up here, when I call this block, okay, see here I am still giving a symbol, a word-sized holding register itself. Internally, I am slicing it, and on top of that, if I want to overlay other structures so that I can still have the possibility of symbolic access, I can make use of that. That is the use of at keyword, at keyword. All the details of this at keyword usage and all these things are available in another FAQ in our support site. I will also be sharing this with you. You can have a look. So all the prerequisites for this, how to make use of this, everything is explained up here. And just to show you, if you have a look at this FAQ was posted in 2016. So this has been there for a very long time. I'm not sure how many of you were really aware or really using this. Anyway, so that is the use of at keyword, at keyword, and using things in that fashion. Right now, what we did was we had the usage of some structure. So we want to group some data. For example, in this particular case, all valve status and a particular byte, I wanted to group it together. That's why I created a structure here, right? This is totally okay, but for some reason, if I want to reuse the same structure somewhere else for some other variable or for some other case, then I have to go ahead, copy paste one by one, or I have to, retype and reuse this everywhere else. So instead of doing that, let me show you another concept that is possible here, which is the concept of UDTs, user defined data types. Whenever you have the possibility, whenever you think of grouping some variables into a single unit so that you use that whole unit as a single element, always think of user defined data types and UDT, especially if by any chance, if you come across a requirement of a struct, that simply points to the fact that you can make use of some UDTs in your case. So what is UDT? How to create the UDT? Let me show you. To create a UDT, you just come to the PLC data types, not the PLC tag, come to PLC data types area. And here you have the option of creating user defined data types. You can give it a name. I don't know, I'll call it valve status. And inside that, you can define the variables as required. So to keep things easy, let me just copy paste this so that I don't have to type it and waste your time. Okay, this user defined data type UDT, now I have made something called as valve status. This looks like a DB, right? If you have seen the interface of a DB, this looks much similar, but this is not a DB. This does not appear as a DB, but because of the creation of these user defined data types, now we have the possibility of using it in our block interfaces or inside DB. So for example, usually when you create a variable, maybe some variable, you have data types available. There are system data types like integer or word or real or data and time. So these are all system different data types available. But if we have our own data types like this, now those guys will also be appearing here now. So if I come down, you can now see here that you have this option called as valve status. So if I open it, this is actually nothing but a struct, kind of a struct created, but now you don't have to type it individually one by one every time. You can make use of this at a single stretch wherever you need it. So I hope you are getting to know where I'm heading to. So previously, using that AT overlaying structure, what I did was I overlaid another structure and I manually created the structure for all those things. Now I need not make it a struct. I can make it valve status. Done. So if you have another holding register which would like to use the same concept, you can make use of this again over there. So UDT is another topic that we are starting to discuss now, and it has much more features and facilities available along with that. The concept of UDT can in fact be used not only inside your, I don't know, maybe not only inside your DBs, FBs and all, it can even be used natively with your IO memory as well. So to show you that, let me go to okay, I have an IO device. Okay, do I have a module? It's an 8-channel module. Okay, let me take I'll take a 16-channel digital input module up here. Okay, this 16-channel digital input module is having the address 5 and 6. So I 5.0 to I 6.7 is consumed by this guy. Oh, by the way, did you see what I just did? If I want to see this area rather than using the scroll bar up, down, left, right, we have this option. If you concentrate your thing over here, there is a small icon that you can use, which will, if you click and hold on it, you will get your area, and you can use it to easily position your screen. So especially when your rack is pretty long and if you have so many things, I've just zoomed in right now. Now if I click on this area, now I can move around and position the view to a particular place whenever it is required. Okay, fine. So I have this input 16-channel input module taking 5 and 6 of the input byte. What I'm trying to show you is I am assuming that this 16 channel input module is going to be completely used for all my 8 valve status, what I have shown you before. So if I go to my PLC tags, I'll make a tag table, and maybe it was I 5.0, and now instead of valves, instead of making it bold, now I can type valve status. So I 5.0, I 5.1, I 5.2 up to I 5.7 is automatically available for you, and you can just either use it or keep it for future use. When you think of standardization, you can think of it this way. Maybe you have a valve and or a motor. For one motor, associated with one motor, you have around 6 or 7 tags. Then instead of using a 16 channel digital input module to combine one motor and some other things, you can standardize it in a way that whenever a motor is there, you will always be using an 8 channel module. And along with the 8 channel module, then you will be creating a structure like this. If you have your FB that we have already seen, your FB input, output, static, all this area can have these area can also have that same UDT reused. Even if you have some DBs that you would like to, so maybe if I have some DB, I want to create some temporary variable for mapping. So map valves, I can make use of that UDT inside this as well. So there are endless possibilities available, but all these takes planning towards standardization. But I'm just showing you the tools what are available to you so that you can take it into a much higher level. Okay, so that was the use of UDT. Just to recap or to summarize certain points what we discussed so far, we saw the concept of slicing access, and with the help of slicing access, we use that dot byte 0 or bits were accessed with the tag dot x0, x1, x2. Word can be accessed with w0, and byte can be accessed with dot b. So with this, multiple higher sized tags can be accessed individually with some less sizes. Second, what we saw, one of the limitation what we saw there was, just if you remember that example of holding register giving us values of 8 different vals, we never knew holding register dot x0 is val 1 or val 2. For that, if you want to have a symbolic addressing, you can overlay another tag on top of a tag. So for that, we use the AT construct, AT keyword. So using the AT keyword, we did that. Now, using AT keyword, we saw that we had to use the struct to make the full use of it. Using struct was totally okay, but if you want to reuse that same structure somewhere else, just like how you can have it, if that input module can itself be used in these cases. So instead of keeping some struct, I made it as a user defined data type or UDT. Now, if you have opened and seen any of the Siemens libraries, Siemens application examples, sample projects available in our support site, you will see a heavy usage of all these options. And they are the recommended ways of doing things. They have even some more, power that they'll be giving you, which we will see in a moment right now. Okay, so that was some bit of demo on different addressing concepts. Let us go to the next one. Handling data. Whenever we have a huge amount of data, or when we have certain data that we use in the program and we want to have it much more readable, we have certain tips that that I want to share it with you. To give you an example, I have made here a small FC. This is a unit conversion FC. This is converting pressure in one unit to pressure to other unit. It's a simple example just for the demo. Both input and output are taking some real numbers, and output is also giving you some real numbers for this. Internally, once you look at it, what you see there is you have the pressure input multiplied by 14.5038, giving out as the pressure output. So As a programmer, you might be knowing what is the relevance of this particular value here. But for any other person who, without having the context when they open and look at it, then for them to make things easy, it is better if you could make use of the so-called constants. Inside a block interface, may it be FC, may it be FB, down there you will have an area called as constant. This constant is nothing but giving a name for a fixed constant value just like this. Advantage, readability. Your code will become much readable so that anyone will understand what is actually happening there. In my case, what I have is, if I remember it right, it is bar to PSI factor, and I'll copy that, and that is a real number, and as a start value I'll give that value there. Okay, so now in my program, wherever I want to use some constants like this, I can make use of this. No change, still it is a constant, still it was the same effect as that of before as far as the calculation and as far as the memory consumption and everything goes, but your code is much more readable for you or for some other programmer, for anyone. Using the constant available inside a block will provide you access to that constant only within that block. So if I want to use this particular bar to PSI factor somewhere inside OB1 or somewhere inside some other block, I might not be able to use that. But if you want some constants declared globally, you also have provisions for that, which is with the help of tag table. If you come to PLC tag table, any tag table, I'm just opening the default tag table, you will most probably be using this area, right? I mean the normal tags what you create. But here, in addition to the tags tab and the system constants, we also have an option called as user constants. These user constants provide you the same concept and the same option just like what we have seen right now, but only difference that instead of giving it locally to one block, we have some local access right now. So if I define pi, and that is a real number with the value 3.1415, something like this. Now in everywhere in my program, maybe in OB1, I can use that constants, or inside another block, if I want to use it, I can still make use of that here as well. So user constants will provide you the possibility to make your code much more readable and much more legible for yourself and also for other users, shall I say. Okay, now second topic under data handling, what I want to say is when we deal with data, so first of all, constant data, this is the first tip, you can make use of the so-called constants, user constant. But other than that, when you have bulk amount of data that you want to use it for some particular logic, then start thinking about array. Array is a very, very powerful and useful tool which can make your life very much easy in many different cases. So to show you that, I have prepared another small FB here. This FB is, I'm just going to do some motor speed calculation. All I'm doing is I have three motor. So motor run feedback I'll be getting. If I'm getting the run feedback, then I'll use that motor speed as the actual speed output. If not, I'll move 0, which means, to keep things in context, let me show this. So M1 run, if M1 is running, then M1 speed sensor value, I'll move it to M1. What happened? Is it a different type? Okay, these are also real. Okay, I'll move it to M1 actual speed. If not, I'll move 0 as the So this is the logic, simple logic. So I have a motor. If it is running, the sensor value will be moved as the actual speed. If it is not running, I'll just move 0 as the actual speed. So very pretty simple logic. But now here, if I want to you do it for 3, it is pretty simple. I just copy paste it 3 times. That same network what I wrote here, I copy pasted 3 times. Now everywhere I have to go and change that M1 to M2. Even for that, I mean, even for that, you have some options. But if you see here, the naming convention what I have used, I'm always following a particular structure, and there was a reason behind that. Since I have followed this, now I know between network 1 and network 2, the only naming change what is there is everywhere M1 that is there, it should be changed to M2. Then my second network is ready, right? That is possible since I followed a standard in creating the block interface and the naming. Okay, but what is the advantage for that? Now that I have it, I've copy pasted the same network twice. So I have for 1 and 2 and all. Now over here, I select the network 2. On the right side, on the task card, if you come to the task card, here we have the simple find and replace option. So I can now just say find M1 and replace it with M2 everywhere you see it and look downwards. So I say find, yeah, it found one here. Replace, 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 replace. Done. My first network is ready. Now I'll just say M3 and replace, 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 replace. You see, having standards in different walks of your engineering development is always helpful. But anyway, this is not the easiest way that I want to show you here right now, but still this is something that good to know. Now that you have it, when you go ahead and call this block, so forget that guy. If I call this block, okay, fine, I can connect some parameters and it will work fine, no problem. Tomorrow I am doing a different project right now, and in my new project, instead of 3 motors, I have now 7 motors, or I have 10 motors. Now what do? I have my logic ready, right? What is the logic required? That is already prepared and it is readily available. All I have to do is I have to scale it a little bit. So how to do that? For that, I'm not even going to show it manually, but you got the idea. You can copy paste things one by one. You can copy paste here one by one and make things a mess. Instead of doing all those, let me show you a different way. That's where I'll be using array. So I'll delete these 2 networks. I'll delete these 2 guys. I'll delete these guys. Except network 1, let me delete the network 2 and 3. I'll go here. So run, I'll say run M, and speed sensor, I'll name it speed sensor of the motor M, and actual speed also I'll make it actual speed of motor. Okay, now instead of making it a boolean, now I'll make a array of boolean, array of bool, array of real. Same here, array of real. Done. Now if I have 10 motors, or if I have 5 motors, I can do 0 to 4 or 1 to 5, whatever it is, it doesn't matter. I just adjust it here. And my block is ready. So run M0 speed sensor M0 actual speed M0 actual speed M0. Same concept. Now if you are going ahead with copy pasting, yeah, still fine. I copy paste 1, 2. I'll show it for 2 times, and here I'll just come to task. I'll say I'll ask for find bracket 0 and replace it with square bracket 1. Replace, 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 replace. And over here, replace it with square bracket 2. Okay, so using arrays is a little bit easy. At least the having this interface changing is actually a little bit easy in this case. Fine. Okay, but now when I look at the block interface, what do you see? block interface is all blown up. Now I'll go to update block call. Okay, now fine. Now if I keep my pointer on top of this, it'll ask me for an array of 0 to 4 of Boolean. So I come here, it is array of 0 to 4 of real, which means now if I have a data block, m data, motor data, some data block, and I'll create motor on. Okay, sorry, yeah, on of motor and array of Boolean of what bool and speed sensor of motor, and this is real and actual okay. Instead of 0 to 1, I'll make it 0 to 4. Done. All I can do right now is I can come to the place where this is being called. I can open up this guy. I can connect that array completely over here. I need not even do connecting the variables one by one. I can fully connect it as a single element, and it internally takes care of all these options, right? Fine. So this is, I mean, so far okay, not that great. So far okay, I would say. But this is not the only reason why I wanted to introduce array to you. With array, I want you to know, okay, let me delete all these networks. So when I write something like this, so maybe speed sensor of 3 moving to speed sensor or actual speed of 3. This first network, writing it this way, and if I just for a moment create a new variable, I call it idx or index, whatever you want to call it, I'll make it an integer for the time being. Now have a look what I'm going to do. If I use a move block, I move the value 3 to that index variable or idx variable, and then in the next network I'll copy that same guy, and instead of m of 3 I'll say m of idx, and even here m of idx. This first network and second and third network combined both are actually same effect, or let me even put it here. I mean, this is even okay. So this network 1 and network 2 are actually having same effect. Now what's the advantage? If I now want to go to the 0th motor, I can make the index 0. I can make the index 4. I can make the index any number what I want, and this logic what I have here will work automatically. Okay. This knowledge I can really leverage if you could, go a little bit into SCL programming as well. Now I know when I say the term SCL, at least a part of you will be, oh, SCL is, I mean, not my cup of tea. It is too difficult. But let me at least give you some, basic background. I hope this is already known to you that even while creating a new block, I can add a new block. Maybe it is an FB, and here itself I can make it either go as a SCL or STL, FBD. These languages I can select it for the whole block, or I also have the possibility that within a block itself, I can have one network. I can have one network as ladder, in between another network as SCL. This is totally possible. The moment I select that SCL network, you see here your favorites region has changed a bit. Instruction folder, if you start digging deep, I mean, there will be, a little bit newer instructions available here, but, things are a little different in this case. Before I show you the full purpose of, converting this into an array and using the SCL and all, let me at least show you how to deal with SCL, at least for simple examples. So let's say I have a switch, which is a Boolean, and I have a lamp, is a Boolean. If you want to make that lamp on, you will just be doing this. So switch and lamp, right, in ladder. The same thing if you want to do it in SCL, the only thing what you do is where you want to save the data, that is lamp. So lamp, you just mention colon equal to and say switch. You end every line with a semicolon. That's it. So this and this is now again the same. If you want to move some, the other variables, for example, if I take a speed sensor, okay, speed sensor of m of 0 colon equal to actual speed of m of 0. This is equal, sorry, you have to have outside. This is equivalent to moving that value into one another. So all these kind of options are possible, but the biggest advantage is once we have the SCL code written like this, we have the option of using if conditions. We have the possibility of using loops. We have the possibility of using, switch case statements. Those things come into picture. Now, I don't have a whole lot of time to teach all the basics of SCL, but let me show what I'll be doing in this case. So the same logic what we wrote before, which was like this. So let me take this out. The logic what I had written before was like this. So run motor 0 and speed sensor of motor 0, move it to actual speed of motor 0. If not, maybe I'll copy and paste this out here. If not, I'll move the value 0.02. So this same network, if I want to convert it into SCL, it will look like this. So I need an if condition to check if this is true or not. For that, I have the if logic. I have some of the tools available here in the favorites area, or if I go to program control operations here, I have so many templates. Once you know the syntax, you can type it by yourself. But at least until then, if you want, you can make use of this, boilerplate templates or snippets, shall I say. So when I call a snippet like this from this, there is a kind of yellowish highlighted area. That is a place where you have to change something. So I'll just mention run m0 equal to true. So if that run m0 equal to true, then what do I want to do? Then I want actual speed of m0 colon equal to speed sensor of motor 0, end it with a semicolon. If not, what I want to do is I want to make it 0.0. That's it. This network and this network is right now exactly the same. Okay. Now, where am I going with this? Let me show it to you. Just like we have if conditions, we also have the possibility of loops. So one of the common loop, what we have something called as a for loop. I'm just taking a for loop out here. The structure of the loop is pretty simple. I have a counter variable. I give a low limit and a high limit. The counter variable will go from the low limit to the high limit. So all I can do is I have that IDX variable which I made before. Let it go from 0 to 4. Now, this loop, once it executes, it will be automatically changing the value of IDX from 0 to 4. Now, if that is possible, I'll just cut that code from there. Let me paste it inside this guy. Okay, and inside wherever I have that 0, I'll just make it IDX now. So IDX, and even here I'll make it IDX. Okay, so that's it. Now your entire code for controlling or for calculating the speed of, you know, I mean, 0 to 4 up to 5 motors is really ready. You don't have to worry of anything else. You can call this and this same block will equally work fine. So I just update instance and block call, done. Now I'm not totally done. I have a couple of more points to say. Now here I have another problem. Now let's say you saw the way I have built this, right? So I have made it now for 0 to 4, and even that dB variable what I made for the mapping, I've made all those for 0 to 4. Yeah, totally fine. But now what is the use of this? What I want to show you is tomorrow if I want to come and change this to, you know, to make it for 10 motors. Now it is, compared to before, it is still easy, but still I have to go and change that 10 at least 6 and 7 places where all things I'll think. So this I'll make it, so this I'll make it 10, and this I'll make it 10, 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 this is 10, and inside the logic and here this is also have to be 10. Yeah, now it is ready for 10 variables. But every time having to do this is really not the efficient way. Of course, we are not here to discuss all those, and this is where I would like to go back to the last topic what we discussed, that is user constants. If I go to the default tag table, I have this user constant. I can make use of this inside my code. How? Have a look. So motor count, and it is an integer. I say that is having the number 10. Okay, once I have that, now I come to my code. Wherever I have kept that 10, instead of keeping the 10 there, now I can keep motor constant. Done. So instead of writing 0 to 10, if I type motor count, since the motor count value is 10 right now, that gives me 10 elements up here. I can do the same thing for all of this. Copy. Not only inside the FB, even inside the DB variable when we declare, I can do that. I messed it up. And since it is constant, I already told you we can access it anywhere. Motor count, done. Now your block is, you know, I mean, so much reusable than how it was before. If your code changes for any reason, and if you, I mean, tomorrow you have a program, you have a project where you are doing it for, you know, I mean, instead of 10 motors, you want to do it for 5 motors, 20 motors, 100 motors. It is just a matter of coming here and changing this variable to whatever you want. So I did that single change. You come here, all your variables are already 30. Inside you go here, all your variables are already 30. Done. So this is the real power of using array. So I said, whenever you want to deal with a large amount of data, it is always better to use array. This was the real reason behind that. Now, of course, I was showing it here by creating all these variables individually by creating that data. Now, this I can again make it one step ahead by creating UDTs if required. For example, if I go here, if I make a new UDT and I call it motor UDT. And inside motor UDT, all I have is the run status, which is a Boolean, and I have actual speed sensor, which is a real number. You can have more variables. I'm just limiting it to 2. Now, once I have that UDT, then instead of creating different variables like this, now I can say this is M TR. Say let's say M motor array of, I can say motor UDT, and even the array of motor UDT, even here this is motor count. Here you have to make the necessary changes. So instead of calling it as just run, it will be mtr dot mtr of idx dot run status, and this will be mtr of idx dot speed sensor. I mean, you can go ahead and make the changes even here. Even this was not required right now. I can have one of them deleted. This is again just motor and array of motor count of bool. That bool, now I'll change it to motor UDT. If I come to OB1, update block call. Okay. And to this guy, I'll just connect that complete array. Same effect. Okay. So, so far so good. Now, before we really conclude the sessions, 2 more small topics I want to discuss here. So far, if you have seen the pattern that I have been showing you, I am showing you different tools and options with which you can make your blocks reusable so that you can standardize your entire thing. You can make your own library blocks. Whenever a new project comes up, you have the option to, straight away call it, reuse it, and you are done with it. Now, on that aspect, if you think of giving out this particular block to someone, so in one project as a programmer, as a developer, you developed this. Now tomorrow you want to give this block to someone. What precaution measure you have to take care? The only measure that you have to take care is that inside this block, everywhere I am accessing that so-called motor count constant. So if the person who is copying this block, person who is using this block into his project, he did not create a constant named motor count, then the entire thing will start failing. You won't be able to, properly do that. So how to overcome this last point? Let me also have a discussion on that. Inside your this, I believe it's a functionality which got introduced in TIA Portal version 15. I guess I may be wrong, but anyway. So any type of array what you create, you can define the sizes. Oh, by the way, I hope you know this. You can define the size 0 dot dot 5. This is how people do. This is okay. If you want to make it, you can make it 1 dot dot 5. That's also okay. Or if you want to keep any other number, 758 dot dot 987. This is also totally fine. But when you access it, you have to access it in that same way, in the same manner. If you want to make it, -5 dot dot plus 5. This is also a valid index for any array. But anyway, I'm not here to discuss that. Instead of defining a size constantly here, because that was the whole reason why they have to rely on this so-called motor count so that they will take the variable properly and all. Instead of doing that, I can say my array, when I'm creating this FB, my array is of unknown size. Okay. Okay, something is messing up. We'll have a look at it. But Nevertheless, if I go here even, I'll make this as unknown size, or rather than putting it under input, maybe I'll put it under in out, if that makes any difference. Oh yes, yeah, so I have to give it under in out, my mistake. Paste. Okay, so all I did was I just put it under in out, but my array size is not defined at all. So what is the catch here? What is the problem here? When I execute this code, I know that I need to know the loop has to run from where to where, because the index will be going from that low point to that high point. By any chance, if you mention an index which is not really available here, it will cause problems. So how to define the limits? Because I don't want to keep this motor count variable as a constant inside here, because then I can't with all ease of my mind, I can't redistribute this block, because I have to tell them go ahead and create a constant with the same name, with the same type, all those things I have to tell them. So this is where we have this possibility. Oh, offline, don't want that. So if you come to instructions under move operations, we have an instruction called as lower bound and upper bound. This instruction is nothing but an option to help you to find the low limit and upper limit. So L bound, let me make a integer variable, for example, and U bound, another variable. So this L bound, and so what does it need? Okay, it need a D int. Okay, fine. L bound, U bound. Now for the array, this array I'll connect it here. This array I'll connect it here, and this dimension is nothing but because while creating array, it is possible for us to create even multi-dimensional array. Array of array can be created. So we are finding the size of each dimension. So I'll just make the dimension 1. Now this gives me a possibility of really reusable block. I don't have to worry anything externally here. Oh, okay. I have to change this though. So L bound to U bound. Done. This block you need, as long as you are sure of the logic what is written here, if you are sure, if you have tested this logic, it works fine, you are 100% sure, then that's it. You close this block, you never have to ever open that again. Whenever you call it, it just takes the size internally depending on what array size you connected here. If you connect here an array of 10 variables, it will be 10 variables. If you make it 30 variables, internally it will find the 30 variables. That's it. So that was the real uses and advantages of having indexing and array concept, and even going ahead with SCL, how much of effort you can really reduce. You can have a look with this. Okay, fine. Next. So even till now, all the variables what we created, we were showing variables that has a particular type. So if I come to an option here, this is a simple example what I'm just trying to show, not so meaningful example, but anyway, I could only think of this. What I need here is I have an input value, and the output is whenever the limit of that particular range is reached, I want the output should be high. And what do I mean by the limit? Let me go to the help for a second of TI portal. If it is an integer that I'm connecting, programming a PLC, I hope you know data types. If you come to just to keep simple, let me take integer data type. Let's say integer. if I am connecting an integer variable there, I know integer variable can go from minus 32768 to plus 32767. So when my value is reaching approximately around 90% of that, so 32767 into 0.9. So when my value is reaching around 29,490, I want a warning to be raised. This is my requirement. Pretty simple. But the only problem is, if I am making such a block, I have to make the block different block for different data type. If I am using integer, I have to play with this limit. If I am using signed integer, I mean short integer, this is the limit. If I am playing with unsigned short integer, this is the limit. Everywhere I have different limits to play with. So how do I deal with that? So all I want to do is just this. So if I value, okay, sorry, greater than, if my value is greater than, now to define those limits, I know these are the constant values. I have calculated, just for the example, 90% of all those, and I have saved it as constants. So if my value is, so in this case, this is an integer, so I should be giving here int warning limit. So that's how my logic is, int one limit. Then I want my limit reached, this output to be turned on. This is what I need. But what is the problem? Tomorrow, if I come and connect unsigned integer or a real number or a double integer, my entire limit and all the range will go haywire. So how to overcome this? Now for that, I want to introduce the last topic that we'll be discussing for today. That is variant. So far, we have seen the system data types. We have seen different data types that we have created. In the same way, we can make it, variant, which means there is no data type I'm giving for that. When you are playing with variant, you almost will have to do the code in SCL, because in SCL, you have some instructions which will be helpful for you in this case. So what I want to find out here first is this value, which is a variant. Let me show you this. If I go to my OB, delete all the previous ones. If I call this guy, which I have made variant, if I keep my mouse pointer here, it says I am getting an output that is a Boolean, because I know internally that is a Boolean. But once it is variant, what do I see? If I keep my mouse pointer here, it can be any of these. This is almost the entire list of data types supported by the this particular PIPLC. It can be Boolean, character, integer, signed, unsigned, anything it can be. So I'm making my block, independent of the data type, even what I have. But how will I manage this then? For that, I have to use some built-in instructions. For example, I have this instruction called as type of. Type of, you give that element, so type of value. This instruction, when you call it, it will return what type of, what is the data type of the variable what you have given here. This will return that. What is the advantage? Now I can put it inside an if condition. For example, if type of value equal to int, then okay, then I'll say if value greater than int one limit, then my limit reached equal to true. I know this is not a real world example, so please bear with me for being a little lame on this. And if, and here instead of ending, I'll say else if. So now I'll copy paste the same stuff, else if, copy paste. Okay, I know this looks a bit weird, but let me show you what is happening in here. Just to give some spaces, I'm not going to run this anyway. So if this is int or if this is uint, and if this is sint, then instead of int one limit, I'll take uint one limit, and this is sint one limit. These three limit variables, not variable, they are constant. So different constants I wanted to use, I have defined them here, or you can give the constant value here. It doesn't matter. All I'm doing right now is I can connect any type of input to my this particular pin. Depending on the data type, my block will automatically consider what limit it has to take, and correspondingly it will give the actual output over here. So that is the concept of variant, and with variant, when you do the programming, all these are the possibility. I'm just barely touching the the surface on this. We have more instructions even available here in SCL if you are interested. So is array. So if a element what is connected, is it an array or not, we can check it. This will return true or false if the element is array or not, or if the element type of element, if it is an array, then we don't want the type, we want the type of an element within that. So type of element, what it should be, we have this. And if you want to move the variant from one place to another, we can't use a normal move block. We have instructions called set variant, was it, or put variant? Oh no, variant. Okay, variant set. Okay, variant put and variant get instructions we will use to, this is equivalent to move block, but when we play with variant, when we are dealing with an unknown entity type, but moving it to a known entity type, we can make use of. So I'm just giving you some glimpse of other instructions what are available, which you can make use of if you move ahead with the concept of variant again. So I'm almost reaching time, not almost, I have already reached the time. So I'm stopping my demonstration here with TI portal. Just to quickly summarize whatever things we have seen, we saw the differences between FC and FB. What is FC, what is FB, what is static, when to use static, when to use multi-instance, what is the purpose of temporary, how temporary behaves within the block call, all those things we have seen. Now, we said as per the recommendation, it is always better to use symbolic addressing because the hardware platform itself is really optimized to handle that. We still have that old type of addressing still available, but know this, that is just kept or that is still available for backward compatibility purpose. So if you have a new project, try your level best to stick with symbolic addressing. And if you're doing symbolic addressing, we discussed that slicing concept. We discussed the AT overlay structure. We also mentioned if you're dealing with a structure, then why not use UDTs? Much better. So we saw UDTs. UDTs could have been used in your input area, your output area, your DBs, your block interfaces, everywhere you can use UDTs. Handling data, multiple constant values if you are using in your project. To make it a little more readable and legible, you can think of constants. Constants can be available within a block interface, or constants can be defined in your tag table also. And of course, when dealing with bulk data, which is, I would say the kind of the highlight topic for today, if you're dealing with bulk data, think of array. Why array? Array gives you the possibility of indexing. And with indexing, if you could switch to SCL, then you can go to even have options like this, where you can have a block which will calculate the array size in runtime when you connect it, and you can, make a library block for your company, forget about it, and everything will be standard. Finally, just like playing with array of unknown size, if you want to play with a data of unknown type, we have the possibility of variant. I was just showing a small example on variant as well. All these topics, whatever we discussed today, so far we have been saying that standardizing things will be helping you in digitalization, because of course, having standards is much necessary. So what do I mean by that? I'm not going into a detailed explanation of those things, but at least assuming that you have followed, you had some plan, you did some standards, you have developed some block following the standards for your company, and you have this, you can really reuse it easily. If you have reached that level, then what is possible? Have a look. I hope you might be knowing that we have the concept of openness. If you have installed yourself TIA portal anytime, then you would have seen that there is a checkbox available asking you if you want to install openness or not. So let me close everything else. Okay. So using that openness, openness basically provides you an API. It's a DLL file that is available for you, with which you can write your own program, which will interact with TIA portal in a way, things are done. Now, how you leverage that DLL, how you write the program is up to us. In our support site, I closed it. Okay, I think I have it here. Okay, this link also I have included in my presentation. This is a landing page where a topic page where almost all the information related to openness is actually made available. You have during the demo, I have shown you the add-ins, TIA portal add-ins. Even the add-ins are developed utilizing that so-called openness functionality. So openness gives you much possibilities for digitalizing your entire, project development workflow. What I have done here, let me say, so I have an Excel sheet. So, assuming that this is your case, I want to generate a project for some machines, but I am assuming that, if I have a machine, what type of modules I'll be using and what kind of program we'll be using and reusable type program and all I have already prepared, I have made it ready. If that is the case, then have a look. On my desktop, okay, there is a projects folder which is empty. Let me copy that project location. So I am telling this Excel sheet to create a project. I want to give the name project 1, that's fine. And I want to save it under this location. Within that, I'll be adding a PLC, and the PLC name I want maybe main PLC. I want to have this block created for maybe 2 machines, and machine 1 name is M1, machine 2 name is M2. And for every machine, I'll be creating a separate, remote IO panel or not. I'll just keep it yes for the time being. So I just, made some sample configuration like this. Have a look. My TIA portal is not open right now. Utilizing that DLL, utilizing that openness functionality, we can develop some things like this. This is just a Excel add-in what is just created. I gave some details here, and this add-in is programmed to look into these details. And the moment I click this, okay, now my hands are off my mouse. I'm not clicking or I'm not touching anything. It is accessing that DLL. That DLL is opening TIA portal. It will be creating projects. And by the way, I'm not the best computer programmer, so my program is actually working very slow. Bear with that, please. Anyway, so if you see, it has already created a project. You can see on the title bar, it is saved in the desktop projects PROJ1 folder. It has made it. Right now, the project tree is empty. No devices are added. Not doing anything. Okay, so now I have a PLC with the same name, main PLC, what I gave there. It created 2 RIOs, it added 1 RIO, it added some modules, saved, done. My project is, I have made this demo just with adding the hardware. But mind you, if you had made the libraries of the blocks, then it is just a matter of accessing libraries and adding those blocks also into your program. But now anyway, just by giving a configuration like this, your project is ready. I don't want to save this, but your project is already ready. If I come to my, oh, sorry, not this. If I come to that desktop, you have that project folder here. Not only this, just to show you maybe a slightly different option, I can even give some additional triggers, or maybe may give the name project 2. Same, I'll call it PLC1, and this time I have two machines. I want it to be, I don't know, maybe MAC1, or I want it to be packing, and I want this to be loading. These are the names of the machines. I don't want separate RIOs for each machine. Some configuration, just some sample. I go here, but now I'll also do this. Okay, I'll just say, run in the background and eventually just give me a archive file, not just the TI portal project, just give me an archive file. If I click on the create, the status message you can see on the column F, it is doing all those things, but only difference is right now you don't see a project, the TI portal window opening up and doing all those things right now. Give it a moment. Okay, so internally it had created the project by now. Controller is added, IO racks added, device networked, done, done. Okay, done. So it says, project is saved and archived. Let's have a look. Don't save this. If I refresh my folder. Okay, it was under the webinar folder. So I think I kept the default name. So under webinar folder, there is a project 2 and there is an archive file that is automatically created. Now this archive file, you can use it just as how you would do the normal archive. But I also kept that project. So if I just open the project, what I just created. Okay, so if I go to device and networks view, first of all, what you see right now, I only have one RIO. I don't have two RIOs because the configuration was done that way. I have kept the default name PLC1 and all, so it is appearing like that. Only one remote IO panel, and if I open this inside, I have more number of modules. So I have the modules DI1, DI2, and DQ1 for the packing and for the loading. So this is just to show you the, in the hindsight, with the help of standardization, with the help of all this, reusable code and all this concepts what we discussed. Once you make your things ready, there are even much more tools available along with TI portal in the background that you can utilize by your own, and so many application examples and library functions available in the support side, which can help you in taking your project and the project development lifecycle much faster. Okay, so I think I took some time extra, but that's it from my side for now. I thank you for your attention. Let me stop the recording and I'll have a look at the chat. So in the meantime, I request you for your feedback once you are at it. So I'll also paste the feedback link in the chat. I'll also have a look if there are any messages already available. Share. Okay, I see some questions, and I'm almost sure most of the questions are, I mean, at least many questions are going to be on the recording. So as you know, the recording, what we are doing for these webinars will be published in our, webinar publishing folder. You can have a look at it. So we only request you to provide your email ID so that later on we can send the presentation. And in this case, I'll even share the sample project, what I created, if it is of any, help for you. And the recording will also be available in that public platform. In the chat. When a UDT is created inside the DB, is it possible to have initial values? Okay, please give your I request you to give your email IDs in the feedback form. It is after the meeting ends, it is kind of a tricky job to collect all the email IDs from the chat. So please make use of the feedback form. The feedback form link is also pasted. Please use that to provide me your email IDs, please. Okay, when UDT is created inside the DB, is it possible to have initial value? There are some settings, but with that, I believe it is possible. I need to check it, but I believe that is possible. How can we cross-check the use of a tag if it is configured as a real and used as a word or int in the data block? I guess that part would have been answered with the discussion on the variant that we discussed, hopefully. Is it possible to generate a FC from source? Just like how you have it for the other ones. I guess yes. I haven't tried it by myself. I guess it is possible to generate the FC and FB from source as well. Can I know what is the use of value status of ST type module if we are going to use module states block for diagnostic at module level? Okay, the value states option, what we discussed, it is just to give you an easy option without having to, write a program. If you want to write a program, and with that, if you want to take the status, it is already there. Yeah, I was just showing you an easy option that is available. If that makes sense for your case, that's it. Can we use AT instruction in an FC and explain the IDB, why it is mentioned as, set in IDB? This, it is really explained in that link what I'll be sharing with you. So why AT instruction needs that IDB and how and where it can be used, that is all explained in that, that FAQ what is pasted. So I'll definitely share that link with that as well. Okay, so I guess that's it on the doubts and questions side. I see a lot of email IDs. I'll try to collect it. But please, if you can make use of the feedback form and give it in that, I would really appreciate it. I'll paste that feedback form link once more. Yeah, you can scan the QR code that you see on the screen, or you can make use of the link what I just pasted. Oh, there is one more. Okay. Can we make fault tolerant connection between CPU 1510 SP with, okay, 400H? I doubt if that is possible or not to form a fault tolerant connection from CPU with 400H. I need to check that with the 400 H team colleagues as well. How to accommodate all the TIA versions in one PC or laptop? What is the basic requirement for TIA version 16? OP, Windows system and PC laptop specification, which can also support the version 13 and 15. Project file, AP file of version 13 can also support. Okay, to your question, Ilyas, to your question, TIA portal right from version 13 onwards, version 13 SP2 onwards, you can install multiple TIA portal versions side by side. When you say TIA portal, we have to be a little more specific. Let's say within TIA portal, you are speaking about the step 7 professional, step 7 basic, WinCC basic, WinCC comfort, advanced, no problem. Multiple TIA portal versions can be installed side by side. There is not an issue. But if you have WinCC professional installed, WinCC Professional utilizes SQL installation and multiple WinCC Professional cannot be installed at the same time. So that is one limitation. But other than that, multiple TIA portal versions can definitely be installed in the same laptop. Regarding specification, whenever any TIA portal version is released, the TIA portal version will be, in the support side, there will be an entry showing the delivery release, document, and also some manuals showing that. So each TIA portal version will have slightly different, hardware requirements maybe. So for that, I would really recommend to have an eye on the support site itself. To show you that here, I don't know if Ilyas is still here. So if I go to the Siemens support site, so let's say TIA portal version 16. So if I search for TIA portal version 16 and I'll say I only want the product note, which will show the release notes. See, delivery release of TIA portal version 16. These links, of course, the manual will definitely contain that, but these links will usually give you the individual requirement for, okay, this is for the entire thing in that step 7. Yeah, here it is. So what is the configuration required? What kind of hardware, software are required for this? This is all available here. So look out for the delivery release for each of the softwares, or of course, manuals will definitely contain this information. So either the delivery release or the manuals will be your good friend to know that information. The project AP file can be supported upgrade. Yeah, okay. Now regarding the project upgrade, version 13 service pack 1 onwards. So if you have a project made in a version older than version 13 service pack 1, then you need to first migrate it to version 13 SP1 at least. And from version 13 SP1 onwards, any project version can be migrated to any other higher firmware, project version, which means version 14 can be opened in version 15, version 14 can be opened in version 16, version 13, SP1, SP2 can be opened in 14, 15, 16. That is possible. But a higher version TIA portal project, like a version 15 or 15.1 project, cannot be opened in version 14. That is not possible. So a lower version TIA portal project can be opened, migrated, archived, retrieved. Everything will be possible to the higher version. But for this, at least you need TIA portal version 13 SP1. Before SP1 project, if it is there, you need to first open it in version 13 SP1, migrate it to version 13 SP1, and from there you will be able to jump up. WinCC Professional SCADA developed in TI version 15 can be upgraded to version 16. Yes, possible. Can same philosophy and programming environment be used for PCS 7? Two aspects. I'm not a expert in PCS 7, so you need to remember that. But on the other hand, PCS 7, the engineering platform is totally different. All these functionalities and features, what I showed in TIA portal, are available inside TIA portal. The moment you move out of this platform, I doubt these functionalities will ever be available or not. Okay, I guess I reached the end of the comments. Okay, so that's it from my side. Thank you everyone for joining. Thank you for your time. I could see that, around a lot of 30. Oh, okay. I mean, up to 100 people were there. Okay, very nice. Very happy to see you all. We will keep you updated. We'll keep